Hello, and welcome to Snax. Today's presentation is What is a P-Value? It is my pleasure to introduce today's speaker, Mr. Ben Ahlstrom. Ben is a statistician at Amgen Inc. within the Global CMC Statistics Department and has been with the company for over 15 years. Ben oversees a team of statisticians in the completion of analyses to support product filings, laboratory analytical methods, ongoing manufacturing, and tech transfer. He leads process improvement efforts to standardize analysis approaches to improve quality and efficiency. Ben provides statistical expertise to teams and individuals in operations and other functions as needed. Mr. Ahlstrom, the floor is yours.
Today's Stat Snack will answer the question, what is a p-value? The objectives are to understand the definition of a p-value and understand how a p-value is used in hypothesis testing. To answer the question, what is a p-value, let's first talk about hypothesis testing. We can liken hypothesis testing to a trial in the American legal system, where a defendant is considered innocent until proven guilty. In hypothesis testing terms, the null hypothesis, HO, is that the defendant is innocent. The alternative hypothesis, HA, is that the defendant is guilty. There are two risks in a trial. Looking at the table on the right, first there is a risk of convicting an innocent person. That is the risk of rejecting the null hypothesis, when in fact it is true. The second risk is the risk of letting a guilty person go free because of insufficient evidence. That is the risk of accepting the null hypothesis when it is in fact false. In the courtroom example, the probability of convicting an innocent person is of critical concern. To minimize the risk of convicting the innocent, overwhelming evidence is required to conclude guilt. To put it in hypothesis testing terms, to reject the null hypothesis requires a high probability, usually greater than 95%. To conduct a hypothesis test, we follow a 5-step process. 1, state the null and alternative hypotheses. 2, set the confidence level, alpha. 3, compute the appropriate test statistic from the sample data. 4, compute the p-value. And 5, compare the p-value to alpha and state the appropriate conclusion. We will now focus on steps 2, 4, and 5. Alpha is selected prior to conducting the experiment or collecting the sample data. Note that there are many software packages available to compute the test statistic and p-value from the sample data. A p-value is the probability, given that the null hypothesis is true, of obtaining a test statistic value as extreme or more extreme than the one we calculated from the sample data. A p-value is generated using the test statistic. After we collect a sample that is representative of the overall population and is of appropriate size, we can calculate the test statistic and p-value. As I said previously, both the test statistic and p-value are easily computed by multiple software packages that are readily available. The comparison of the p-value to alpha determines if you reject or fail to reject the null hypothesis. The smaller the p-value, the greater is the disagreement between the sample data and the null hypothesis. Thus, the smaller the p-value, the greater the evidence to support the alternative hypothesis. The table on the right provides 4 possible decisions that can be made. If the null hypothesis is in fact true, we can either fail to reject or reject it. If we fail to reject it, we make a correct conclusion. If we reject it, this results in a type 1 error. We generally set the probability of a type 1 error, alpha, to be small. The typical value is 0.05. On the other hand, if the null hypothesis is in fact false, we again can either fail to reject it or reject it. If we fail to reject it, we make an incorrect conclusion. This results in a type 2 error. We generally keep the probability of this type of error small as well. However, if we reject the null hypothesis when in fact it is false, we make a correct conclusion. To illustrate, we'll cover two examples. The first is a one-sided test where the null hypothesis is that the mean is equal to 0 versus the alternative that the mean is greater than 0. Alpha is selected to be 0.05. A probability of 5% of incorrectly rejecting the null hypothesis when the true population mean equals 0. After the sample data are collected, software is used to calculate the test statistic and p-value. The p-value was calculated to be 0.26 and is represented by the red shaded area under the curve. We either reject or fail to reject the null hypothesis based on statistical evidence. Because the p-value was greater than 0.05, we fail to reject the null hypothesis and conclude that we do not have enough evidence to say a difference exists. We say fail to reject the null hypothesis instead of accept the null hypothesis because this decision does not prove the null hypothesis to be true. Example 2 is a two-sided test where the null hypothesis is still that the mean equals 0, but the alternative hypothesis is that the mean is not equal to 0. As before, alpha is selected to be 0.05. After the sample data are collected, software is used to calculate the test statistic and the p-value. The p-value was calculated to be 0.056, and this is represented by the red shaded areas under this curve. Note that because this is a two-sided hypothesis test, the shaded area is split into two with an area of 0.028 on the left and 0.028 on the right, for a total probability of 0.056. In this example, we also fail to reject the null hypothesis because 0.056 is close to, but is still greater than 0.05. We don't conclude that the mean is equal to 0, but rather we conclude that we don't have enough evidence to indicate that the mean is different than 0. So in both of these examples, we fail to reject the null hypothesis. In summary, a p-value is a probability. In hypothesis testing, a p-value is used to indicate whether there is sufficient evidence in the sample data to reject the null hypothesis. If the p-value is smaller than alpha, you reject the null hypothesis. If the p-value is larger than alpha, you fail to reject the null hypothesis. The smaller the p-value, the greater is the disagreement between the sample data and the null hypothesis. Thus, the smaller the value, the greater the evidence to support the alternative. Thanks for joining me today for this Stat Snack. Be sure to connect with us on the AAPS CMC Statistics community.